program, your problem isn't operation. You've got operation down, right? I mean, you know how to run the machine. Yes. Are you in the same room as me?
What?
You know how to run the machine, right?
Yeah.
Okay.
For the most part.
So here's what I'm going to do. On this particular project, the way that we run this part is like this. We'll use 1x2 stock. We're going to saw it 3 1/4 inches long. First operation is to hold it out of the vise 3/4 of an inch to the left-hand side. So here's my vise. Here's my part. Okay. I think I have a blue around here too. My first goal
Is to mill the one side sticking out,
this side, yes.
go in, go up, and go out.
Yes. In, up, out. Okay. So G41, G40. So I got a start point and end point going up like this.
Yes.
Okay. So that's all I have to do. Second operation.
Is on the other side of the part,
Yes.
it's going down all the way.
Mhm. Yeah. So on the second the second side of this, the second part of this is you're going to come in here and do this.
It's just the reverse of
It
it.
is. Okay. So that way your cutter is continuously on the left-hand side of the part, both times. This side goes down deeper. This has to go down
All the way.
It does.
So
Yes. Okay. And it says remove only 62.5 thousandths from this
the total thickness.
total thickness is what it says. So that means here we have our part. That's off each side. So you're going to remove 1/16 of an inch off each side. Okay. So I did not mean to do that. Okay. So we're going to take off the back side. We're going to take off at 62 thousandths. Top side we're going to take. The second side we're going to take off 62 thousandths. So all I want to do, I'm going to grab one more color. I've got a green. Thought I had a green. Okay, now. We're going to go ahead and go in and just kind of map out all these moves. No, green. Let's see. Use one of these guys. So these will be my moves. I don't have green, so we're going to faith null across it. So in creating our program, we're going to use Notepad to start it. And I'm just going to shove it off to the side over here. So we won't be able to, actually maybe I'll put it over here. Okay, so there's only so much screen, so we'll make it work as we go. When writing the program,
Or start a percent sign.
exactly. Now you will not use a percent sign if you're writing the program at the machine. You're just going to start with program number and go. So we're going to then make our program, we're going to go ahead and do a caps lock. We're going to do O, and then whatever 4 digits that you want to make for the program name. Okay. The next thing I want to have is some information about how I'm setting my part up. Okay. Now, it may have said, and
It said 1 inch away from the vise. I stuck out the vise for the first operation.
okay, but it doesn't say. It only tells me how I want to pick up the second side. So what I want to do is I want to probably go ahead and probe 4 and 11 using the probing system. If I don't want to do that, still my X0Y0 is going to be in the middle, and I just use an edge finder for it. So the advantage in making the center of our part X0Y0.
Because you can do the same thing on this side and just turn to negative.
Bingo. So I can do some symmetry on this part.
That's
All
not really, like, the problem is like the numbers and, you know what I mean? Figuring out which code,
Okay.
what code means what.
Gotcha. So one of the really helpful things in the book is that a lot of the code, like going to the code list of G codes and M codes sometimes helps, but going to the examples of it, like contouring or to
Like this one,
see.
it's spot drill.
Yeah, and so that's really helpful. Also, so you know how the program starts out by kind of looking at startup lines, and then we have our most common used G&M codes, and then cutter compensation. So I like to look at some of these things. Like here is circular interpolation. That's something we did a little bit of today, and then we also have how to use can cycles, and it's got examples of all those things for you. You know, so sometimes you can see those, and sometimes it's easier. Here's some different drilling, some jumping up and down over clamps, and some of that other stuff. So some of those things will be beneficial too. This is a good one because it gives a description right next to every single thing that we do. All right, so you know the movements that you want to do. All right, so if we use 4 and 11 in our probing, we've probed the center of the stock.
And sides.
Yeah. So we know X and Y, where the middle of it is, and then we did a single touch in Z, so we know that it's the top of our part. So here's our program. We're going to keep our probe in 1, so that means we're going to start our program off of 2. Yes.
3-inch shell.
Okay. And so 3-inch shell mill will be able to make one nice swipe across there, be good to go. So I can do M6, and I'm going to call this my 3-inch shell mill. Okay. Now on newer machines we can invert. It could be M6 T2, it could be T2 M6, doesn't matter. So we've got that in there, and then we're going to do a startup line of G0, G20, G40, G80, G90. Rapid movement, inch input, cutter comp cancellation, can cycle cancellation, absolute programming.
Okay.
That's on startup lines. Both of those, or all of those commands are listed there. You need to know those because G0, if you had a G1 or G2 or G3 active and you bring in a G0 at the beginning of your program, it'll cancel out all those things. Now, we don't hardly ever run a metric. We've never ran a metric in your classes. So all of our machines are currently running in G20. But if I put that inch input, it just takes one code, and then I don't have to worry about it anymore. Cutter comp cancellation, in case somebody stopped the program before I got to the machine and they were in the middle of cutter comp. Sometimes we'll go over to a machine and we'll stand there for 10 minutes trying to figure out what's going on with it, not realizing that somebody either had it in cutter comp, in a can cycle, or in an incremental.
So you only need to put that code once?
I put those at the beginning of my tool changes.
Right.
So I put it at the beginning of the program and every tool change. That way I can start up the program anywhere. Now, there's a sequence restart or a starting at any point in the program too, but this is always a good habit to start. So I gave you 2 examples in the book of common startup lines, and are all of those things necessary or not? So let's look at those. Okay, is a safe start necessary? And here are some examples. 2 things. Two the same thing. See, one has the G90, G54, G0, and the other one has just a G. Well, they're just kind of rearranged differently. Some information's there, some information there. Which way is one better than the other? Is was kind of what I'm asking you in there. So I've got my X0, Y0, my Z0 on the top of my part. I've got my shell mill not started yet, but I'm getting pretty close. So I want to go ahead and call up my work offset G54. At this point, I'll typically go ahead and make my X and Y movement. I wouldn't have to, but I would like to go ahead and combine some stuff. So if this part is going to end up being 3 inches long, where do I need to start my shell mill at? Because this is going to be...
Or you want to at least be a little longer, so negative 3.5.
Negative 3.5 will be pretty darn good. So we'll do the shell mill in red, and let's just say this dude is a 3-incher, and it is going to be X minus, what did you say, 3.5? Mm-hmm. Okay. And it's going to be at Y0, right? Because this is right on center line. So X is going to be X minus 3.5.
And Y is 0.
And Y is 0, yes. Make sure you have periods after there. Periods matter.
On periods, do you put on in everything?
I put it in everything that's a whole number. So like if, obviously I've got 3.5 here,
yes, but
I don't put a period after the 5. I put it after the Y0. But like if I had a spindle command after that, S3500, I would not put it there. At the end, like if I was going G1 4.5, just a point at 4.5. Just a place where it needs it, and it needs to designate a whole number. Because if I just put X, Y0, it'll go to the smallest possible scenario. Which in this would still be the same thing, 0, 0. But if I wanted to go to 1, and I didn't put the decimal point, it would go to 0.001.
Right.
See what I'm saying?
Yeah.
Okay. So I've got this part started. I've got my tool called up. I've got my safe start kind of set up. I've got my X and my Y. I don't have any kind of spindle speed, and I don't have any kind of downward movement yet. So do you happen to remember what the spindle speed was that we used on that?
1018.
1018 is what sounds correct to me too. So S1018.
Mm-hmm.
So no decimal point after that. That's just a number. Okay. That starts my spindle up. We pre-calculated that by using the 3-inch shell mill with I think it's probably it's a 3-inch shell mill. It's got 5 inserts in it, and it is in aluminum, so probably a 600 surface footage. I think it's probably what we had used on that. So that starts up our spindle. Next thing we need is a G43. G43 gives a signal to the machine to say we're getting ready to put a height in here. So when we put that height in there, the height that you put in the tool library in geometry,
Yeah.
that's where it's going to draw from. So we're going to put G43H.
H2Z.
Well, you will put a Z, but right now you're going to have H2. So that H matches the T. Okay? And then you're going to go ahead and put a Z of 1 inch. So now it's going to go down a 1 inch above the part. And so I want to do a couple of safe moves there. So we're going to do 1 inch above the part, and then we're going to go Z 100 thousandths above the part. And that's still in rapid, because up at the top, we underneath that T2, there's a G0, so that's a rapid move, so we're in rapid.
Okay.
We have not went into a feed move yet. Now I want to go, I'm going to do this, I'm going to go G1, Z minus 0.0625. On a G1, I've got to have an F command. So F is the feed rate. Feed rate is in inches per minute. Do you remember what it was? 77.
41.
What?
41.
41. Okay. So 41 needs to be a whole number. So 41 point. All right. So now that set me down to that 62 thousandths to take off the top part of that part. I'm down at the feed rate that I need to be. Now all I got to do, I can G1 and get over to where I need to be. I'm already in G1, so essentially all I have to do is go X, then the positive side of that number. So 3.5. And so that's where our symmetry comes out. And
That would, by putting that in there, it would take it across.
it does. It's going to feed right across at the 41 feed rate. Okay, so that feed rate modal stays the same until we change it. So we've gone across here. We're done. All we got to do is get it out of the way now.
So how many inches you call it?
So to run the next one, I should just have to surface probe it and take the difference off from the Z, right?
Shouldn't do anything now. Just
Put it over against the vice but
Vice stopper now. Yeah. You like it?
well, this was the trash part. Threads look nice. It's undersized for overall length. It's
So this is good and this is not good?
yeah, I think it's at like 2.95.
Okay. And
Which
so
you didn't have a plus or minus on that, so I figured 20 thousandths. Since it just said 3.
there's nothing in the drawing or what?
You just had 3 in there, so.
Okay.
So I was assuming 20,000, which 2.95, but it's still
Not made that.
not like that.
No.
Just grab my calendar.
So you might move your work offset up by 50,000 to get yourself at 3.
Okay.
So just where you went down some, at your negative 19 or whatever, so just bump it up by 50. That should put you right on line.
Okay.
So now, as I need to get away from that, I'll show you a couple of different ways that we can get out of there.
I don't know if I'm going to engage his part or not. He gave me one to run.
I would not.
And I'm like, dude, I don't
No,
think this is what Justin's been asking for, so. Yeah.
Because ultimately, I don't care about widgets. I care about, I know how to do the thing I need to do.
Can you hand program this?
I'm not sure.
Because I know it said adapting, but I didn't know.
The adaptive is the way that milled that 3/8 diameter.
Okay.
Yeah, if we wanted to do that, we could do that in just one sweep down. And I can show you a couple different ways to do that if you'll remind me next time we're in class.
Okay, because I think that'd be a good one too. Hey, this is the G code for hand doing this.
So it's just a lot of G2s and Z moves.
Okay.
So you're going to just spiral down, spiral down, spiral down, spiral down, spiral out, and up.
Okay. Cool.
Okay, so now what I would probably do here is if I wanted to be really, really, really thin on my code, I would do a G0 rapid move, Z 1 inch. And then I might just do an M01. That way it'd get me up and out of the way. I can inspect my part to see if I'm happy with it. Now, lots of times I would tell you to do some stuff like this. G28, G91, Z0, and then G90. That'll get you up and out of the way. Spin will go all the way up out of the way so you can get a good inspection for it. When you do that, you have to go into incremental, so you have to go back into absolute. Okay, so see here, see if I were to just put G28, all of my axes would go home, X, Y, and Z.
And that would take the table over.
Exactly, and where you are could cause you a problem or could not. So you got to be careful about those things. You can't leave it in incremental, but when you combine these two codes together, G20 and G91 and Z0, makes the spindle go all the way up and out of the way. G53 will do the same thing. So you can do a G53, Z0. Essentially, if 1 inch is enough to get you out of the way, you're good to go after that. You don't have to put those in. So you could just do that. To be 100% honest, you could put none of these things in here, put an O1 or an M1, and then put a tool change in there, because tool change has to go all the way back up. So it could actually,
But you don't need change tools. Yeah, you need.
You will need to change tools. This is just a couple of different ways of doing this. I think everybody's got their own kind of groove on this. So I think it's kind of important to figure out what your groove is. Like when I'm writing a program or running a program that I've just ran, I kind of know the things to look for. I know my far lines are typically my startup lines, and so I kind of just, like, I've written enough of them, I kind of I know how the block of the code lays out, and I pretty much draw or write it out the same way every time. All right, so now I'm ready to start. I'm done with that shell mill. I'm ready to go into my next, my half-inch end mill and start running the sides. So that's going to be M6, T3. We'll just put half-inch, 2 flute, end mill. Okay, so I can borrow this code here, just copy and paste it out. For all intents and purposes, we would actually be able to not even put that in there. We've not moved away from 54. All of these things stay the same. We should just be able to stroke on through, not even put a work offset, just put a.
Just in case.
Exactly. If I don't have sequence restart turned on, setting 36, or if I stop my program midway and I want to start at a tool but I've not run anything else, I want to give myself some safety factors in there so that I can get started back up again. Okay, so I'll do some of the same stuff. All of these things will be brought back into it. But there's just going to be a little bit of different X and Y values. So we're going to have a Y value.
Negative 2.5.
Okay,
for
next.
X, and negative 2 for Y.
Okay, and then what do we have for an RPM? Do you remember?
4,800.
4,800. Okay, and so now I've got T3, so my H3, H and T have to match. So I go to 1 inch and I go to 100 thousandths. I'm still in a rapid move. On this side, I need to mill the entire height of that part. So on this side, my end mill needs to go there. Over here, it just needs to be like that. Okay. So you already got the numbers from that. That's good. So we'll go ahead and go on down. Our part is just shy of 1 inch, but our top of our part is Z0. So we're going to go down to Z minus 1 should take care of us. Okay, so that's still in a rapid move. Now what I'm going to do is I'm going to feed in G1, G41, D3, and then I'm going to go to X minus 1.5. And put a feed rate, what was the feed rate?
77.
77. Okay, so on that line, I've started out over here. Okay. Now, I did this, I came down. Here's my cutter comp line turning on. I'm going right here. Okay. So I turned cutter comp in a move here, even though it's lineal, it probably moved a little bit diagonally since my cutter comp was turning on at that point. It's okay, it doesn't matter. I'm getting over here. This is negative 1.5. This will then be positive 1.5. Don't really need a positive there. Okay, so here I am ready to start this travel up. And now I'm going to go to, I'm already at y minus 2, right? So in keeping that symmetry going, I'm just going to go to y positive 2. Okay, from there on out, so I'll just travel up to y, 2 inches, plenty of room, more than enough room. Now I'm just going to travel back here. You with me? Are you on cutter compensation?
Yeah.
Okay. So all I'm doing is cutting up this side. So I came from here to here, turning cutter compensation on. You with me?
Yeah.
Then I travel up here. That's this move. It's right there. Okay. Now I got to turn it off and come away from it. G40 X minus 2.5. And that turns cutter comp off. So this move is right there. This move is right there. Make sense?
So G1, G41, and D3X, that turns cutter cup on?
No. This turns cutter comp on in a feed move. The X is the positioning of it.
Right. So
This is a feed move.
right.
These two, this is cutter compensation to the left. This is what diameter are you using? Well, you're using tool 3, so your diameter comp has to be 3.
Okay, so the D3 is diameter.
Got to match that.
Okay. That's,
So you got a couple things. They all have to match. All 3 of those pieces in that string need to be the same thing.
right.
And so that's just the X position, and then that's just the feed rate. Okay, then we're going to go up to Y2. We are going to turn it off.
Then go over.
It's got to turn off in a feed move. So we've got to feed away from it. You can't just do a G40 at the end of it. So that takes care of that. Are you with me there? Okay. I'm not sure where Sean is. I was really hoping he'd be back here. Okay, I'm going to erase some of these things. Okay. I'm going to move up in this program some. So we're not done with this tool yet. So all we did was we came over here, we turned cutter comp off. Now we need to move up.
Over and just do the opposite.
And then we're just going to reverse it. It's super simple from here on out. Okay, so I've turned cutter comp off. I'm going and I'm in a feed move, so I'm going to go G0, Z.1. That puts me up above my bar. Now I'm going to go to X 2.5. Still in a rapid move. I'm going to go to G1, and I'm going to go Z minus 0.650. Yeah, because I think I said that the part needed to be sticking up 3/4 of an inch. Okay. So I don't need to put a feed rate on there because my feed rate from here still tracks. So now I am over here at this point. I'm going to move up just a little bit, and then we'll just draw some arrows as we go. All right. So I've rapided can't see the Z move, but I'm down where I need to be. Now I'm going to G1, G41, D3, X 1.5. So I'm right back where I was. I'm right here again. So same, these two things are mirror images. And so I'm just going to go like right there. Okay. So now I'm going to feed down in Y. Is it -2? Yeah, it must be.
Yes, please.
Okay. Now I'm going to do that same G40 move. Go into X 2.5 maybe. Okay. And so I'm done. Like that's the whole backside of my part. So now all I got to do. Yeah, well, I need to finish this program out. So I could do a G28, G91, Z0, then G90. I could do a G53, Z0, you know, whatever I want to do. And then I won't put an M01 there, but I'll put an M30 there, and then a % sign into my program. Yep. So good to go there.
Yes.
Okay. So okay. So you're tracking every single thing with that. Cool. So let's talk about the other side. Other side gets a little more complicated, but not terribly. I think, you know, it's really good, especially in those kind of beginning moments, to kind of draw the thing out as you go.
I have a drawing on paper.
Yeah, it helps. I mean, you're welcome. You take as many pictures and stuff as you want, you know, just as we're going, to just kind of help remind you of what we're doing. I'm going to go ahead and just, since I'm already here in this notepad, I'm going to go ahead and just keep on writing on it, because I'm not planning on running this. So I will start out with my shell mill again. I'm going to change my numbers just a little bit, but I will go ahead and just kind of do a duplication of this. I'll call this 1. Okay, the only thing that's changed here is where my X0, Y0 is. We milled that one side all the way down, and then we milled that one side shallow. We flip it over. We wanted that one side to be milled all the way so we would have a good corner to pick up on. So now we can come in here and do top single probe in Z, and then a corner probe for whatever corner that might happen to be. Actually, probably 1. So I've got my shell mill, turned it on. I need to change both my X and my Y. So where do I want my shell mill to start out at? Same thing as we had it over here.
Negative X -1.
X.
Y -1.
No. That's probably more for the end mill. So X0, Y0 is down this corner. Okay. I've got to come off the part at least an inch and a half.
So it's 2 inches thick.
2 inches?
Yeah.
Okay, let's go -2 inches, and Y 1 inch. Okay, that puts me in the middle.
And also
Off. Yes,
He's
off to the edge. So see how all that stuff kind of stays the same? That's why I really encourage people to, if you have a laptop, and you can be sitting here doing on the laptop as I do it, you can copy and paste along with me. Where when you're, I like the idea of doing it on paper, but man, it is hard to copy and paste on paper and do it with the same amount of speed. So like a couple guys, Brandon, he's one of the guys who is quick to be on the laptop as he's doing it. That way you don't end up having to go over to a computer and work off of it like that. No pad will run on any kind of Windows cheapo computer, so you don't have to have anything fancy. So if you got a laptop, it won't hurt you to have it. So we've got to overcome at least 3 inches plus the radius of our tool, which is 1.5 inches. So
it's 3 inches long, so do 4.5.
at least 4.5. 4.5 will take us off the edge. So let's go 4.6 just to be on the safe side. That takes care of us. We're off of the part now. We're done. You know, we're done with that. Okay. So now I'll go ahead and grab my 1/2 inch 2 flute end mill, and I'll go ahead and grab 2 out here. Copy that. Paste that in. So there's my tool. There's my startup. My X and Y changes. My spindle speed stays the same. This stays the same. This will change. Let's see, what will it change to? It's got to go down 1/2 inch. Now, here's the tricky part on this. We actually have to mill down lower than 1/2 inch because we took 62 thousandths off the top of our part. This is really the one and only program that will run like this. From now on, I want the top of the part to be Z0. So in here, the top of the stock is Z0. So that means we've taken 62 thousandths off here. So to cut down 1/2 inch, we've got to cut down 562. Make sense? Overcome that area. Yeah, I thought you were Sean. Okay, so I'm now down to 62.5. But I did not put my X's and Y's in order yet. Thank you. Trying good? Happy with it? Good. Looks good.
Wish the chamber was a little bigger, but it's in print, so.
Yeah. Yeah, it looks nice.
I didn't know it was sweet.
That end mill is sweet. I'm hoping to. I can't do it this budget year, but as soon as this budget year is over, so July, I will probably buy. It's probably the end mill that I'll be going to for now.
Jeff goes, you're the only one in class who can get one of those two.
But honestly, luck of the draw. I didn't want to go get my keys. And the only reason I did that is I didn't want to go all the way upstairs, grab my keys, come back downstairs, get into the tool room, and then come
You
back.
said those were like double the cost of our card bindings?
Those are about $75 a piece. That's what we paid for them. That's not that bad. I think that MSC sells them for like $130. We paid $75 for those. So I'm gonna start doing those in 1/2 inch, and I think I'll probably start doing them in 3/4 inch. So hopefully next semester.
The bad part is those will cut right through bikes.
Oh yeah, those will cut right through anything.
I know.
Yeah.
Bike styles, who cares?
I'm super happy with them. You can't hardly spin them fast enough. You can't hardly feed them fast enough.
So are you going to write us a program and fix the bike styles? Or?
Well, I think we will write a program to
Take
fix the
classes.
vice jaws.
Okay.
Yeah, I might, if I get ahead, I might do some work on it ahead of time. But other than that, a lot of the guys who are in this were 101, and so like Laban made some really janky soft jaws, and I want him to hurt as he has to fix them. So
If you want them to hurt, I got a detail grinder at work that will hurt them, and they can come in here and burn it.
yeah, could do that. I don't want to spend the whole semester on it, but I do want them to feel the pain that the moves that you make have repercussions.
I will tell you what I put the detail grinder used to cut stuff with, but we don't want to do it.
Right.
Put in an 1/8
And,
inch carbide and they'll go.
Sure. Yeah.
You
Yeah,
guys did that,
definitely
you come out with like this.
You can easily come out missing digits.
It's
That's
pretty
a terrible. It's a terrible weight loss program.
He knows how sketchy it is. That detail grinder spins at
Yeah. It's
2,200 RPM,
yeah.
I
I mean,
think.
it can take off. That's for sure. All right. We've got to come. We've got to position our tool somewhere around here. I think you already had the number of 1-1. We've got to turn cutter comp on. We've got to go around this part. We're already at depth. We need to figure out where we want to start at. I think you had already told us X minus 1, Y minus 1. That's a little far out to start, but that's going to be fine for us getting going. Okay, so that means up here I'm going to hit X minus 1, minus 1. Okay? So there I am. I'm already at the position of where I need to be. So what I need to do is travel from there. I need to come into this line.
So that corner is 0, 0, right?
It is. This
So-
corner right here. So I want you to travel in X to this edge that I just drew.
It's negative. I mean, it's 1.2588 coming, right?
What's that?
1.88.
0.18.
Yeah.
8.
So
Don't overthink it. That's all you got to do. You've now created this tool,
it'll be positive 0.18.
8. Positive 0.188. So I'm going to go G1, G41, D3, and I'm going to go to X 0.188. Now that drives me right to that edge. Okay? So now all I got to do is go up all the way to here. So where is that?
Could. Right? 1.8.
Got to go to step 1.875. Y 1.875. Next, so I'm just reading the print now. I'm going to go to these 4 points.
Then you go X to 0.813.
Yes. And then down to Y of what?
1.875 negative, right?
No. We don't have symmetry anymore because zero's here. So what is this? Look, there it is right there.
1.2.
0.125.
Yeah.
Okay. So I'm down there at that bottom edge. Now I need to come all the way back over here. This move gets a little bit different than what we've had before. So we're going to go all the way across here, and I actually want to travel beyond that. I want to go all the way to X of negative 1.
So you would put X negative 1,
Mhm.
and it'll just take it right across it.
Yeah, just going to go right on past it. X minus 1. I mean, if I'm trying to really, if I'm going to make a million of these, I've tightened my moves way up. But for what we're doing right now, it's okay to be just a little bit chunky, come off there, just a little bit of haircuts. So now I'm going to come down here to Y of minus 1 and turn cutter trump off. Okay. Okay. From there, I have milled I've milled the bottom side, now the top, I've milled both sides. I've milled these edges. I've milled all the way around this slot. Only thing's left. I'm over here at negative 1, negative 1. Okay. I need to get in here and I need to cut this slot. Here's how I want you to do this slot. There's an easy way to do this slot. There's a hard way to do this slot. I want you to do it the hard way. Anybody can do it the easy way. So I want you to go up this side, going G41.
Then go down, going G42, right?
I actually want you to go up the other side and go up G42. So here's how if I'm going to make this part. I'm going to come up this side I'm going to turn cutter comp on G41. I'm going to come around and I'm going to go down and turn cutter comp off, all in G41. But I need you to make sure that you know how to use both G41
So
and
you
G42.
want me to go all the way up and come right back down?
I do.
I remember you saying that.
Yeah. So I'm going to change some colors here. So I want to do this is your G41 side. This is going to be your G42 side. So would I machine it like this under normal circumstances? No. But I want you to know how to do both of these things. You'll rarely use G42, but if you know how to use it and you don't use it, that's okay. But to need it and to not know how to use it, that's a problem. Okay, so here I am. I'm over here. I need to travel over to here. I can travel straight from here and turn cutter comp on right here. Kind of a long move, but I can do it. So let's do that. We're at a negative 562 right now. We need to be a quarter of an inch plus 62 thousandths. So what does that put us at? Quarter of an inch plus 62 thousandths. Math it out.
Say plus 2. Plus which one?
You gotta have your quarter inch dimension plus your 62 thousandths that you already took off the top of the part. So it's a quarter inch plus 0.065.
It's 6. You said 6 point what? 25? Is you point. Is you 0.875 plus
0.25 plus 16th inch. You did 0.25 plus 0.65. 0.65.
is you 0.31252.
0.3125. So 5/16.
Here's both of these.
Okay. Thank you, sir.
And then I'm gonna put gauges up here, but I'm not gonna know.
Yeah, I would not bother.
I'm tearing the machine in.
Yeah, that's good for him. So.
I was messing with John. Staff Sergeant, yes.
That's fun. Yeah, that's cool.
Okay.
They just keep flipping them. That's cool.
They're not, for some reason, when we put the calipers on and measured this, they didn't come up square.
Did you square them when you put them in?
Yeah.
With the square?
I used the 4-inch square to put them in.
So did you?
And beat the crap out of them when I did.
So let me ask you this. The vise, the bottom of the vise is like this, right?
Right.
Did you have that blade that stretched all the way across both sides?
No, that was my problem.
That's
right
your
there.
problem. Yeah. So you need to have that blade stretched all the way across it. Now, otherwise it's not.
So use the thin side instead of the.
Yeah, thin side needs to go down. Thin long side needs to go down first. Yeah,
Gotcha.
that way you can span that out much further.
Okay.
That's why I don't like people using the 1-2-3 block for short stuff like that because it's too. And it's really hard to do that because your material's 1 inch and your 1-2-3 block's 1 inch. It gets stuck inside there.
Well, the way I look at it, you gave us squares in a box, use them,
Use
but
them.
I didn't realize to
Yeah.
flip it that way.
Yep, you're good.
So, They both came out to 3.13.
3 inches for 130.
Yeah.
That's 130 latitude on.
But you didn't give us an overall, even with taking off the 5,000.
How come before you said that they were 2 inches 950?
That's what the first one came out as. And then whenever I came in here and asked you if I should adjust my Z, you told me to take off 50,000 or 0.005, which I did.
Point oh five. Yeah.
Well, there's my problem.
It's all right.
So-
Okay. Are you sure they're that far off?
I measured them using Ed's calipers, which is better than my calipers.
Well, that.
Not unless I just mismeasured completely.
I think you mismeasured. Look, these are all the same. Like you might be off a couple thou, but you're not off. You're saying they're off of an eighth of an inch. 130,000 is just over an eighth of an inch. Funny.
I was thinking 50,000 chambers for some reason. So, you'll get a kick of that if you can manage to read it.
Follow simple instructions. Dang tool probe. Justin wants to slit your throat, or our throats. Yeah, because we break his stuff. Those are all true statements. They're all true statements.
And that was the statement it was supposed to start with.
Oh, okay.
Justin wants to slit our throats. But, yeah.
I quit.
And then I went to this because, my tap not here, so there's that.
Okay. That sucks.
I was trying to start it back up to M3 S100 to run the kind of a little bit deeper. So I only need like 200,000. And I bumped down an extra line by accident.
Right.
Boom!
Yeah.
I'm so done.
Yeah. Need to start at the startup line. That's for sure. Unless you have sequence restart.
That's why I started leaving those spaces between blocks. Is that way you start at the space. You go back up to the space and go down.
I like to always start on tool change unless I have setting 36 on, so that I can knock it out. But
Don't know what 36 is? Don't want to know yet.
setting 36 will be a huge help to you. You just have to remember to turn it off and on, because if you don't, it makes it really, really labor intensive. Or not labor intensive, but time. It takes a lot of extra time to do that if you don't. So.
I would love to see this thing running just for some reason.
It's okay. This is more high performance than that is though. So.
Now those, we actually use those at work. They're
Yeah.
just high-speed steel,
High-speed systems, big
super low RPM,
Yep.
low feed rates. Just let it chomp.
Right.
So I got permission to start trying to build a new AR. I'm going with an AR-10 body. What I want to build, I can't find a barrel for.
762 by 39 hour.
Nope.
I was about to say
500 Auto Max. It's based off the 500 Smith & Wesson.
No, I know
pistol
what you're
cartridge.
talking about, but why? Why ain't around?
Remember I go back home with my dad's house? Go with my young and let her shoot them on home with it. Or 3, because it's going to punch through the
Just
bird.
do one
312?
of those big slugs.
That's what we said. 312 on depth.
But
Yeah.
Okay.
I
So.
can't find a barrel anywhere. I'm going to break down that machine, and I guess I'll leave gauges. You want me to leave gauges piece with you, or no?
Yeah, that'd be fine. You can put it on the desk here.
Okay.
Okay, so we're at 312 for our depth. We need to get over to this ledge. We can really just travel this way and turn cutter top on. So we'll travel over to 2 inches, 318.
Because I have a box of 3. I looked the other day, I have a box of 308 for some reason. I don't even have 308. I got people just giving me boxes of ammo. Don't even have calibers.
We always do the,
Okay, that turns it on.
It was
We're going
considered
to travel up to
3 different barrel manufacturers.
Y of 2.5. Then we'll travel G40 X2. That turns cutter comp off there. Okay. So, Yes, here till 5 tomorrow.
All right.
Okay, so this is this move. This is this move. This is this move. Okay. So now, to cut this side of it, we've got to be back down here. We've got to run low to high.
So you would want to move spindle up.
Yes.
So that would be next move. So
Okay, good.
you don't have to go Z.
Yep. So I'm out of cutter compensation, so I'm going to go to
Z.
G0, Z.1. Just get it up over above it. And so now I've got to go,
Back to where it was. So
I need to go somewhere around here,
yeah. So
turn it on. So I could go over to maybe X at 2.5. I always want to find an even number. So we'll go X 2.5, Y, we'll just go -1 just so we don't do any math. Okay. Now we're going to go G42 D3 X 1.688. Then we'll go Y 2.5. And then we'll do G40 X 2.5. Okay. So that took us
here,
back
there.
to roughly here. This takes us to here. This takes us up to here. And this takes us to there.
And then you'd be done.
Yeah, I'm done. Completely done after that. And so now, turn cutter knob off. I could go grab probably something like this. And then my program's done. And maybe after this one, I may put a Y0 there too on the next line, but I wouldn't need to, so that just gets my spindle up and out of the way. Make sense? Okay. So I want you to go ahead and run this program. Have you ran already your first operation on your speed handle? So you need to run this project. You need to get that speed handle project worked in. After you do that project, yeah, everything from that feeds into this. So the new thing to this will be doing some holes.
Yeah, that would.
Yeah, G81, A2, 83. Yeah.
Those go.
No, I'm sorry. G81, G83, G84. So no G82 out of there. So we'll be, and G85 we'll be doing everything on this is holes. The steps on this, you're going to do almost the exact same thing that you did on this first program. You can actually use that same program, just modify it some. Then on this side, you take this 3-inch shell mill, come up this side, come down this side, G41. You don't even have to face this part off. And then after you get your steps in shape, then you drill and ring these 5 holes on this spot on the side, drill and tap 4 holes on this side. It's less work than probably what it looks like. But you need to get this guy done first before you do that. When are you gonna have this part done? You gonna run it today? How late are you here till?
I can run today.
Okay. It'd be good for you. Start to get those things caught back up.